Do 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 do. Alright, and welcome to video number 1 of 2 on classifying chemical reactions. So we're going to look at 5 different types in this video. You should have looked at all 5 of these in grade 10, so they should come as no surprise to you. The 5 general types are combination or synthesis, decomposition, single replacement or displacement, double replacement or displacement, and combustion. And we're going to go a little bit further with that in our second video and add acid-base reactions, but for now these are the 5 that you should be familiar with and that we're going to look at together here. Okay, so the first type is a combination or synthesis reaction. So this is where 2 or more substances react to form a single new substance. You take a look at that word combination, you should realize you're putting things together. You're going to get something new out of what you have before. So our example reaction here, nice simple one. We have sodium, which is solid, plus chlorine, which is a gas. And notice it has a little subscript 2 because chlorine, remember, is diatomic. All we can do with these 2 simple things is put them together. So when we put sodium and chlorine together, you guys should realize that gives you sodium chloride, NaCl, and this is going to be a solid. We'll talk about how to predict what state these are in later on. So we've combined these to form a single new substance. We've got one substance combining the sodium and chlorine. We always want to make sure we balance these afterwards. So the chlorine's not balanced, so let's put a 2 here. That means we need to balance the sodium as well. So we have 2 Na plus Cl2 yields 2 NaCl. If we want to write this in general form, this would be A plus B, so 2 simple reactants form one compound, A plus B together. All right. Reaction type number 2, this is decomposition reaction, where a single compound breaks down into 2 or more simpler products. This is just the exact opposite of the first one, of a synthesis or a combination reaction. Decomposition is where you're breaking something apart. So even that word decomposition should lead us to think about breaking it apart. These are very easy to recognize because if you take a look at this, we only have one reactant. So we have iron 3 hydroxide in this case. The only thing we can do if we have one reactant is to break it apart. So if we take a look at this reaction, this one's a little bit trickier, so I'm just going to tell you what this would break apart into. It'll break apart into Fe2O3, which is a solid, plus H2O, which is a liquid. And this might not look like simpler products at first, but it is. This contains 3 different types of atoms, iron, oxygen, and hydrogen. This product only contains iron and oxygen. This contains only hydrogen and oxygen. So this is simpler. Most of the ones that you'll be asked to classify are going to be easier to recognize as this. But regardless, you take a look and a decomposition reaction will have one single reactant. Again, just like always, we need to make sure we balance these. So the iron needs to be balanced. So let's put a 2 here. And I believe we need a 3 here. That gives me 6 hydrogen, 3 and 3. That's 6 oxygen and 6 oxygen over here as well. Like I said, this is basically the exact opposite of a synthesis or combination reaction. So when we write the general form, it looks the exact opposite. So we start off with a compound AB, and all we do is we break it apart into A plus B. Let's look at the third type of reaction. This is a single displacement or replacement reaction. This is where one element replaces a second element in a compound. So it's a single displacement because we have one element bumping another element out of a compound. So we can recognize these because in these types of reactions, you're going to have an element by itself and you're going to have a compound. So in this reaction here, we have copper by itself, and we have silver nitrate here. So when we get a question like this, we should immediately think single displacement. So we know this single element is going to bump something out of here. Now, when we want to actually predict these products, which I'll be getting you to do shortly, we have to know which is this actually going to bump out. Is the copper going to bump out the silver? or is it going to bump out the nitrate? So the thing to remember, and the thing that makes sense, is that if the element is going to form a cation, it will replace a cation. So we'll just write a cation replaces a cation. So remember, cations are positive. And similarly, if you have an anion will replace an anion. And those are your negative ions. So in this case, copper will form a positive ion. So what's it going to bump out here? It's going to bump out the silver. So copper bumps out silver. Silver's on its own. So we'll have Ag plus, now we'll put copper with nitrate. Remember, copper is multivalent, so we don't know what charge it should have here. So if we don't know, we just go with its most common charge. And if I take a look at my periodic table, copper's most common ion charge is 2 positive. Nitrate's a 1 negative, so when we write a balanced compound, this should be CuNO3 2. And then again, we have to go ahead and balance it. So copper's already balanced, silver's balanced, nitrate is not. We've got 2 nitrates, so let's put a 2 over here. That unbalances silver, so we'll put a 2 here as well. So remember, in a single displacement or replacement, you recognize it, you have one element and one compound. Cations replace cations, anions replace anions. Now, with those single replacements, we have to be careful. We have to do one additional step, and that's looking at the activity series of metals. If this was during school, you would always be given this. I would write it up on the board. For now, you can just either print this slide off or copy it somewhere, but you will always have this as a reference. So what this is it lists metals in order of decreasing reactivity. So what that means is the higher up they are, the more reactive they are. And what I'm going to tell you here is a reactive metal will replace any metal listed below it. So in other words, the more reactive element will end up in the compound. So the first thing we have to do is look at if this, say, okay, it's a single replacement, what is going to actually end up in the compound? We've got lithium, and lithium forms a positive ion, so it's going to bump out, if it's going to bump out anything, it's going to bump out the potassium here. So whichever one is going to end up in the compound is the more reactive. So if I take a look over here, lithium is more reactive than potassium because it's higher up. So what that means is lithium will end up in the compound. Potassium's on the outside looking in. So potassium gets bumped out, and lithium, with its 1 positive charge, will go with hydroxide in a 1-to-1 ratio here. So if I just use a different color here, this one was more reactive, and this one was less reactive. And the more reactive one will always end up in the compound. So let's take a look at a second example here. We've got iron plus aluminum nitrate. So again, we recognize this as a single replacement because we have a single atom by itself, or a single element by itself, and we've got a compound. So again, iron would form a positive ion, so if it's going to bump out anything, it's going to bump out aluminum. Let's take a look at aluminum and iron on our list here. Aluminum is right here. Iron is down below, so the more reactive is aluminum. So what that means for this situation, this is the more reactive one. And like I said, the more reactive one has to end up on the product side in the compound. So in this case, it's already in the compound. So is iron going to be able to bump out aluminum? No. So there is actually no reaction that takes place here. So that's something new for you from grade 10 to grade 11, that no reaction will actually take place if the more reactive one is already in the compound. If we write the general form for a single replacement, you would have A, which is the single element, plus BC, which is your compound, and A is going to bump out either B or C, depending on whether it's an anion or a cation. So let's just say it was a cation, so B will get bumped out and A will go to C. It could also be an anion, and in that case it would bump out C and you would have BA, right? So you just have to be careful about that. Number 4, double displacement or replacement reaction. Similar to the last one, except it involves the exchange of positive ions between compounds. So you have two compounds, they're just going to switch their positive ions. These usually take place in aqueous solutions, that means in water. So we could even just add that, in water. And they usually produce a precipitate, that's something solid. This is a solid, a gas, or a molecular compound such as water. So I've already started to balance this one because I had this one here. Sorry about that. But we have sodium chloride, so this is a compound. We've got magnesium sulfide, this is a compound. So we have two compounds. All they're going to do is exchange their positive ions. So sodium and magnesium are going to switch with each other. When you do this, all you have to do is make sure that you balance those compounds. So the first one will have magnesium and chlorine together. So that will give us MgCl2. Magnesium is a 2 negative, chlorine's a 1 positive. And this is going to be aqueous. Again, we'll talk about how to predict those states later on. And sodium will now be with sulfur, so we'll end up with Na2S, and that's also aqueous. All we did was we switched the positive ions. So you had two compounds switching the two positive ions. And because I already had this 2 here, because I forgot to take it out, this is already all balanced for us. The general reaction for this one is AB, that's a compound, plus CD, that's another compound. And A and C are going to switch with each other. So you'll have CB plus AD. And it doesn't matter which one comes first. So in this example, if you wrote sodium sulfide and then magnesium chloride as a second, if these two just were in swapped positions, that would be totally fine. Totally up to you. All right, our last type of reaction is a combustion reaction. And I alluded to these in my other video. It's an element, a combustion reaction is where an element or a compound reacts with oxygen. This is the important thing. It reacts with oxygen, often producing energy in the form of heat or light. Complete combustion of a hydrocarbon always produces, and we talked about this in our other video, hydrocarbon contains carbon and hydrogen, just like this one, and they always produce carbon, let's go with that, carbon dioxide and water. Those are always going to be the products. So in this case, we have C3H8, that's a hydrocarbon, plus oxygen. This is the part that tells us this is a combustion reaction. We're always going to produce carbon dioxide, which will be a gas, plus water, which we'll also write in as a gas here. Predicting the products, super easy. Balancing, we talked about that. This is the harder one. So let's go ahead and try to balance it. 3 carbon on both sides. Let's do hydrogen next. So we need a 4 to give us 8 over here. And then I have 4 plus an additional 6 is 10 oxygen. So I'll throw a 5 on here. So that was pretty easy actually. But remember, these combustion reactions are ones where you might end up with a 0.5 here, and then you would just double all of your coefficients. One thing to note, we didn't tell you this in grade 10, is that compounds other than hydrocarbons can also undergo combustion reactions. So I've already written it all out here for you, but here we have sulfur plus oxygen gives us sulfur dioxide. So in this case, we recognize this as a combustion reaction because it's reacting with oxygen. We didn't create water because there's no hydrogen. We didn't create carbon dioxide either. But just be aware that if you have a reaction with oxygen, it is probably going to be classified as a combustion reaction. And in fact, this one we could also classify. So classified as combustion, or if you were swift, you would have picked this up. What are we doing? We're putting two things together to create one more complex product. This is also a synthesis reaction. So you could classify it either of those two ways. So I want you guys to go ahead and practice this. So you would have already done the balancing portion of this, but I would like for you to now go ahead and do the classifying portion of that worksheet.